Back and looking at some examples here, which again I'm apparently blocking. Okay, so what we're looking at here is converting coordinates to the other system, and I guess that depends on what system we're starting in. So here we're starting with an r and a theta we want to convert to x, y. This happens to be the easiest direction to convert because if we look at our little formulas here, we know the r and the theta, so we're just going to plug them directly into these formulas to get x and y. So x is r cosine theta, that's 7 cosine pi over 3. This is a number that we just know from the chart. Same thing for the y, and we get 7/2, 7 root 3 over 2. Leave it alone, there's no reason to convert these to decimals, although this one's a nice 3.5. This one is not going to be as nice, it's 7 times whatever that decimal is, and so we'd get some decimal. Leave it exact if there's no reason to do otherwise. Second example, this time we're given an x and a y, and I had to tell you that because it's possible that we could be at 0 radians, and then you wouldn't have known what kind of coordinate this was, but it's an x and a y. Here a diagram is kind of very helpful. The xy coordinate is negative 4, 0. That puts the point back here on the left-hand side. Well, I don't have to go through formulas at all to recognize that the angle to go straight left is pi. And the amount of radii that you'd count off would be exactly 4. So 4 comma pi is done. That's it. Sometimes you don't need formulas. Next example, another r and a theta. Again, direct application of the two formulas, r cosine theta, r sine theta. I made a little sketch though. 5 pi over 4 is just past, as we know, 4 pi over 4. So we're in the third quadrant. And in the third quadrant, sine is negative, cosine is negative. So knowing in advance we should be getting a pair of negatives, it just helps. But we're looking at cosine of 5 pi over 4, and I'm using the reference and signs. It's equal to the opposite of, negative of, because of quadrant 3. Cosine of pi over 4, the reference angle, so negative root 2 over 2. Same idea for sine, and this time we get negative 3 root 2 over 2, and the same for the y coordinate. Finally, the last one of these coordinate conversion problems, I'll have to look down at that work. We're looking at 6 root 3. So again, I drew the diagram. Over 6, up 6 root 3. We're looking for the r and the theta to go along with the x and the y. I can see that the theta will be a first quadrant angle, positive, positive. That's where we end up. So if we start to take a look at what we'll do this time, now we are using the formulas. R squared is equal to x squared plus y squared. We have those two numbers. Be careful with squaring 6 root 3. We get 36 times 3, 144, and the radius is 12. Now I know you would say, well, wait, aren't we supposed to do plus or minus 12? Well, not in polar. When we're dealing with polar, we'll pick off the positive radius. That's what we're going to be using. And I can see it from the diagram anyway. The angle itself is going to be the inverse tangent of 6 root 3 over 6. If we cancel those 6's, that's the inverse tangent of root 3. You should have some faint bells going off that this is a chart value. It's pi over 3 for that angle. So 12 pi over 3, correct polar coordinate. The next set of examples that I left for you to wrap this up, this is looking at, I can't even get myself out of here. This is looking at converting equations now. So if we have x plus 2y equals 5, this time the easier direction to go is to convert from a rectangular equation to a polar equation, because every x, every single one becomes an r cosine theta, and every single y becomes an r sine theta. Direct substitute those two. It's usually we want to solve for r if we can. This is an easy r to solve for because we're going to factor out the r. There it is. All the rest gets divided. So r equals, and there's our equation. This is a line. So is this. In fact, it's the identical line written in its polar form. And we'll look at graphing as our next topic. X squared plus y squared is 25. This one a little bit easier because x squared plus y squared is directly r squared. So I could say r cosines and r sines. No reason to when x squared plus y squared goes right to r squared. R squared is 25. Therefore, r is 5. And again, like I said on the previous page, we stick with the positive r equals 5. You may recall what it is. Circle of radius 5. This is an easier way to write that circle. Just says radius is 5. That's the circle. Last couple of these, wrap this up here. R squared equals 6r cosine theta minus 5. We want to take a look. It's a little more difficult going from the polar. So we need to work with our equations that we've got over here. And we're going to potentially use all of them because r cosine theta is just x. So we replace this with an x. R squared is x squared plus y squared. And as soon as every r and every theta is gone, we're finished, we're done. These can often be a little bit more complicated to try to solve. There's nothing to solve for here. I could solve for y. I'd end up with some kind of plus or minus square root because it's y squared. This is probably the easiest way to leave the equation. Finally, r equals negative 2 sine theta plus 7. A little bit lengthier this time. We're looking to get rid of the r's and the thetas, and we want to try to be creative with this. And sometimes this direction from polar to rectangular is the toughest direction, unless things are just sitting right there like were up here. But r doesn't work nicely. R squared works better. And there are two ways to turn an r into an r squared. One is I could multiply by another r, and the other is you could take whatever you have and square it. Multiplying by an r gets me r squared. Squaring it gets me r squared. So you really want to look at what's easier to work with. I don't know that I want to square this whole side. That's going to be complicated. So in this case, I multiplied both sides by r. R squared, 2r sine theta, and 7r. The first two pieces now do convert directly. R squared, like we saw in the previous, and r sine theta is y. Problem is, we are now stuck with a new r that just appeared. So what I did was I added the 2y to both sides to get everything on one side, isolating the r. And this time, rather than multiplying by r, because that's going to throw a new r over here that I'll have to figure out what to do with, and I already have this entire left-hand side in terms of x and y. This time, squaring both sides. So when I square the 7r, I get 49r squared. I am not going to square this out. I'm just going to leave it as quantity squared. And it equals 49x squared plus y squared. And I'm happy with it because there are no r's and no thetas. And that's where I want to be. Could we multiply through by the 49s and start work? We could do a lot of things. Stop, stop, stop. And I'm going to stop too. I'm going to put out 2 more videos. One that shows you how to graph polar on your TI-84, and another that shows you how to graph polar on Desmos, since we're sitting at home with our Chromebooks. We're going to take a look at both. Feel free to look at both, neither, or just one. And that's it for now. See ya.